Okay, let's take a look at our second question. So they give us some information here which we've seen before in a previous past paper question. We've got an acid dissociation constant for ethanoic acid, 1.74 times 10 to the minus 5. They want us to write an expression for the acid dissociation constant, so we're going to do Ka for ethanoic acid. Now we know that it's going to dissociate into H plus ions, and it's also going to be the corresponding negative ion, and that's all over the original acid concentration. And we're going to use that when we calculate the pH in the next question. So in the next question it's asking us to calculate the pH of a 0.41 molar solution of ethanoic acid at this temperature. So we can use, because we've mentioned the temperature, we can use the acid dissociation constant, and we just put everything in that they've given us. So they've given us this, and they've also given us this, and then we need to work out this. And we know that the H plus ion concentration and the ethanoate ion concentration are going to be equivalent. So essentially we need to work out the H plus ion concentration squared, which would be the value at the top. So we've got this, we'll work this out, we'll get the H plus ion concentration, and then we'll just minus log. So it should be fairly straightforward. So let's see how we get on. So we're going to put these figures in. So for Ka we had 1.74 times 10 to the minus 5, and that's going to be equal to the H plus ion concentration squared over the original concentration of the acid, and the original concentration of the acid was 0.41. So by the time you do that, you should come out with 7.134 times 10 to the minus 6, because we're just doing 1.74 times 10 to the minus 5 times 0.41. So that's what we should come out with. Now we need to take the square root of that to give us the H plus ion concentration, because we've got that squared, that's that value. So if we do the square root, it will give us the H plus ion concentration, so fairly straightforward. So that should give us a H plus ion concentration of 2.67 times 10 to the minus 3. If we minus log 2.67 10 to the minus 3, we will, to work out pH, because this is the H plus ion concentration, if we do minus log of that, we should come out with a pH of 2.57. Okay, the next part of the question, we're going to calculate the pH of a buffer solution formed when we've got potassium hydroxide added to the ethanoic acid. So to do this, we're going to use an ice equation again: the initial, the change, the equilibrium, or the end. We're going to also try and put in what they've given us. So for H plus ions, OH minus ions, and then the salt, at the start we've got 0 salt, 0 hydroxide, but we need to calculate the H plus ion concentration, and the H plus ion concentration is 25 times 0.41 divided by 1000, V times M over 1000, and that should give us 0.01025. The next thing to do is we work out how much potassium hydroxide has been added. So we've got 10 cc's of a 0.1, so it's 10 times 0.1 divided by 1000, so that's 1 times 10 to the minus 3. So that's how much we've added. That will form 1 times 10 to the minus 3 moles of the salt, and we will use up 1 times 10 to the minus 3 moles of the acid, making that salt, or reacting with the hydroxide, whichever way you want to look at it. So by the time we do those calculations, So we've got 0.01025 minus 1 times 10 to the minus 3, and that will give us 9.25 times 10 to the minus 3. We will have used all of the hydroxide up, so we're not really bothered about that. It's the salt that we've got at the end. And we're going to use these two figures in our Henderson-Hasselbalch equation. If you haven't seen the Henderson-Hasselbalch equation, you need to go and research, you need to go and have a look. I think it's the easiest way to work out these concentrations, because to work out the pH, because the pH is equivalent to pKa plus the log of the salt concentration over the acid concentration at the end. So essentially what we're saying is that if you get the log of our salt concentration, which was 1 times 10 to the minus 3, and we divide that by the acid concentration, which is 9.25 times 10 to the minus 3, and then you add that onto pKa. Now pKa is just minus the log of Ka, and they've given you Ka, so it's minus the log of 1.74 times 10 to the minus 5. So let's see if we can put all of those things in. So our minus log of 1.74 times 10 to the minus 5 is 4.759. The log of 1 times 10 to the minus 3 over 9.25 times 10 to the minus 3 equals minus 0.966. And we add those two together, and you will get a pH, and this would be your answer, of 3.79.